Hi, good morning. My name is Dennis Jin, EVAR14CS319, and I'm here to do the third experiment of Linux Lab. So our first question here, our objective of this experiment is to show understanding in looping control statements in shell programming. Our first program here is to write a shell script to print the Fibonacci series. This is a program for the code. Program for the Fibonacci series program. We input the numbers, read the number through a variable, initialize number 1 and number 2 to 0, then we print the given value of number 1 and number 2, because in a Fibonacci series 0 and 1 are always a constant. Then we give initialize count to 2, and while count is lesser than or equal to the number we have initially inputted, we do the following. Number 3 is equal to expression the number 1 plus number 2, and echo new line, we print the number 3, and then we give the value of number 2 to number 1 and the value of number 3 to number 2. So initially we're just we're adding up the sum of the series and then giving the next value to the previous value, and then we add the whole thing up again. So count is equal to expression count plus 1, and then we're done with that series. The output of this program as you can see, it's very slow, so I'm going to pull up to my record here. Yeah, so I have entered my numbers is 15, and it prints the first 15 values in the series. Yeah, so our next shell script is to find some of the following series, and the program for that is echo enter the range of the series, input that range through a variable n, sum is equal to 0 for I is equal to 1, I is less than or equal to n, I is equal to I plus 2. You do the following after. A is equal to $I slash star $I again, sum is equal to expression $sum plus $a, and you echo the sum of the odd series, which is $sum. So it basically takes the input as your n, and it prints the value up to n. So I've given my range as 8, so it calculates the values of that particular series, odd series, as 165. Yeah. Oh, sorry. If I give the value of enter the range of the series as 18, it gives the sum of the odd series as 165. Nextly, we have a program to check if a given number is Armstrong. This would mean if a number such as 153 is entered, the square of 1 plus the square of 5 plus the square of 3 would equal 153. Okay, so let's take a look at the program. So 1 squared, 1 to the power 1 plus 5 to the power 5 plus 3 to the power 3, and that should give you 153 as your Armstrong number. If it does not give you that same particular number, then it's not considered an Armstrong number. In the case of 12313, if you take the powers of the individual digits, um, sum does not add up to 12313, and thus it's not an Armstrong number. Our code is displayed here. Enter the number, we read that number, length is equal to number, sum is equal to 0, we initialize to 0, whole number is equal to the number we have inputted, and while the number is not equal to 0, we do the following here. Remainder or REM is equal to number modulus operator 10, number is equal to number divided by 10, power is equal to echo REM raised to the power length, and pi pc, sum is equal to sum plus power, and that concludes our while statement there. And if the sum is equivalent to the old number, then give our old number as the Armstrong number, and if not, if this sum of the individual digits do not add up to the the number itself as a whole, then it's considered not an Armstrong number. So this while statement here, it basically takes apart the digits, 153 for example. It would characterize the number, the individual digits, and analyze it based on that. Our next program is to check if the given number is a palindrome or not. And to do that, we are inputting a number first, read n. So we enter a number n, and we have a temporary variables here, st, which we initialize to 0, reb, which we initialize to just blank, on $n. While n is greater than 0, we do the following. N modulus 10 is equal to st, n is equal to $n divided by 10, and reb is equal to echo $reb $st. Yeah, so done. That concludes our while statement there. And if $on is equivalent to $reb, then we print our number as a palindrome, or else we don't. So what this program basically does, it takes the, for example here, it takes the number 424 and checks if it's a palindrome. So it basically breaks apart the number into individual digits, and then it checks whether we have a mirror image of the particular number. So 45424 would give you the result as palindrome, because it's essentially a mirror image of itself. However, the number 2422321 is not, and the output is accordingly displayed. Our next program is to write a shell script to print the prime numbers between the given ranges. Our program is right here. We enter the initial value followed by the final value, and for I is equal to mu, we have I is less than n and I plus plus. So for the following for statement, we set the flag is equal to 0. For j is equal to 2, j is lesser than or equal to I, j plus plus. Do if I modulus j is equal to 0, then flag is equal to 1. That concludes our first the previous for statement, and then we have another if statement here. If the flag is equal to 0, then echo I, and you finish the program. So this is our output for that program. We enter the initial value 0 and enter the final value, which is 50, and it basically prints all the prime numbers from 0 to 50. Our next program is to write a shell script to sort the elements of an array from ascending and from descending orders. Okay, our program is not fully shown, so okay. So this is our program here. Okay, so we first enter the number of elements. We entered into a variable n1, and for I is equal to 0, I is lesser than or equal to n1. We increment the value of I and do the following. We print the value of expression 1 and read the array. And this segment is to input the array. And next we have and then we have the code for that. For I is equal to 0, I is lesser than or equal to n1. Increment the value of I. Do for j is equal to expression I plus 1. J is equal to n plus n1, and increment the value of j. Do if the first value of a is greater than the last value of the next value of j, then x is equal to the value of I in the array A, and then we set the ith value of A equal to the jth value of A, and we give the value of j in array A as x, and then we have a switch case statement giving us a choice of ascending to descending. So we enter our choice as C, and if the choice is ascending, we have a for loop here. For I is equal to 0, I is lesser than or equal to 1, and 1, I plus plus. And you print the value of the array. Else if we have given our choice as descending order, then we have a different for loop here. For I is equal to n1, I is greater than 0, and you decrement the value of I, and for that statement you print the ith value of in array A minus 1, and you keep looping in that for statement till the given statements are met. And if anything else is printed, you give your option as wrong choice. Our next program is oh yeah, that is the end of our program. This concludes our experiment here using looping statements. Thank you.